Okay, I'm going to have a crack at question 24. You should have read the question. If you haven't read the question, obviously you can stop the video and read it now. But the idea of this one is that a popcorn kernel has got steam in it. Well, it's actually got water in it, first of all. But when you heat it up, the water turns to steam, and steam shoots out the bottom, and the corn shoots up the top. So broadly, this is like a rocket. And anytime you think of rockets, you think of momentum. So you're going to be using conservation of momentum, probably. And whenever you see things moving up and down, you're probably going to use a little bit of Suvat as well. So Suvat, where S is the distance, U is the initial velocity, V is the final velocity, A is the acceleration, T is the time. You're probably going to have to use that at some point. Right, so what we've actually got here is that the time between the two photographs is 83 milliseconds. So the time equals 83 milliseconds. And what's happened is we get this all the time in Suvat. They've said maximum height here. And at maximum height, the velocity is equal to 0 meters per second. Right, so V is equal to 0 meters per second. And you will need to find out the acceleration due to gravity is 9.81 newtons per kilogram, or meters per second squared. And what else do we know? This distance, we're going to find that out because we've been given a scale. So you're actually going to have to say, well, I'm going to need to measure this distance between probably approximately the middle of each is probably fine. So we're going to measure that distance there. And we're going to convert it using the scale to work out how many centimeters it is in real life. So determine the maximum height, so you measure. And when I measured it, it came up to about 7 centimeters in real life. But the scale was about 2 centimeters is only really 1 centimeter. So that the maximum height is about 3.5 centimeters. So using a scale, they're saying that this distance on the photo is equal to 1 centimeter. So when I measure that with a ruler, this is actually 2 centimeters. So what that means is the scale is actually just dividing. You measure it, divide by 2 to get the real amount. Okay, calculate the initial speed. Well, here we go. We're going to have a Suvat question. And we know the maximum height is 3.5 centimeters, but we always do meters, so it's 0.035 meters. U is the initial speed, what we're trying to find out. Vmax is 0 meters per second. Acceleration is 9.81 meters per second squared. Time, we don't need to know, because we're trying to find the initial speed. Well, when you've got distance and U, V and A, and the one that you use is V squared equals U squared plus 2AS, and we're trying to find the initial speed, so U squared is equal to V squared minus 2AS, and that's equal to 0 minus 2 times 9.81 meters per second squared times the distance, which is 0.035 meters. And when you do that all together, it comes up as about 0.84 meters per second. So you're going to get a number and then you're going to have to square root it. Right, okay, the average water content in a popcorn kernel is 14% of the total mass. So, okay. A kernel is heated into a pot, steam is ejected downwards, right? So this is what I was talking about, the rockets. So we've got some of this is water turned into steam, and some of it is corn. So we've got 0.86 of the mass, and we've got 0.14 of the mass going down. Why that's important is because we're going to use conservation of momentum. And because this part has got more mass, when it explodes, if you like, this is going to go more slowly. More mass, more slowly. and this is going to go faster because it's got less mass. A bit like a bomb. If a bomb explodes and most of the mass goes up, it's going to go more slowly than the small part which goes down. Right, so let's look at what they're telling us. Steam is ejected downwards and the pop kernel moves upwards at an initial speed of 1.5. So let's do momentum before equals momentum after. Now, it's not moving before, so that means the momentum after has got to be equal to 0. There's no momentum before. So the momentum after has got two parts. We've got the steam going down, which is the mass of the steam times the velocity of the steam. And we've got the corn going up. So we've got the mass of the corn times the velocity of the corn. And because these are moving in opposite directions, when we add them together, they must equal 0, so they need to be equal and opposite. So the mass of the steam times the velocity of the steam is equal to the mass of the corn times the velocity of the corn. And the good thing is we know enough because we are just trying to, these are ratios, so you can say, well, the mass of the steam is 0.14 m times the velocity of the steam is equal to 0.86 m times the velocity of the corn, which we know is 1.5 meters per second. Right, we can cancel out the m's because the same on both sides of the equation. And again, if you're not following this completely, these are timeses. Sometimes it's confusing if you've got decimals, fair enough. So I'm going to now try and find the equation to show that the velocity of the steam is equal to 0.86 divided by 0.14 times 1.5 meters per second. And when I do that, I'm in my calculator, I'm going to do that. It should come out to about 10 something, a little bit less than 10. So 0.86 divided by 0.14 times 1.5 is equal to 9.2. Well, I'm going to help you understand this. 9.214 28571 is what my calculator says, meters per second. But obviously that's nonsense. I can't have anything that accurate because I've only got two decimal places in here. I've only got two significant figures all the way through. So the only sensible way of writing it is equal to 9.2 meters per second to two significant figures. You don't really need to say to two significant figures. Done. Now, notice I didn't even bother putting the mass of the unpopped kernel in because we didn't actually need it because it's going to cancel. So just save me a calculation. So, and that's the answer. So the speed is equal to 9.2 meters per second. I'm not going to write it on the next page because that won't work on the PDFs. So that's it, done.